Tonellerie Vicard is one of the world's leading brands in the production of oak barrels, serving the wine and spirits industry. Founded in 1875 in Cognac, France, the company has a long history of developing traditional barrel-making techniques combined with modern technology to create high-quality products that meet the strict needs of winemakers around the world. Vicard uses premium oak from famous French forests, such as Tronchet, Allier, Limousin, the U.S., and several other countries. Each region has its own distinct wood characteristics, which directly affect the flavor of wine when soaked in the barrel. French oak is characterized by a light aroma and soft tannins, while American oak has a stronger vanilla scent and is sweeter. The wood is carefully selected, using only old tree trunks from 80 to 200 years old to ensure quality. After being cut into stave, the oak is naturally exposed to the open air for about 24 to 36 months. This process helps to remove tannins and stabilize the wood structure. Natural weather conditions, alternating rain and sunshine, play an important role in creating the characteristics of the wood. The exclusive Vicard Generation 7 technology is a breakthrough of Tonellerie Vicard. Instead of toasting the barrels with direct fire, the company uses a temperature and time control system using infrared rays. This method ensures high uniformity between barrels and minimizes the impact of smoke, helping to retain the pure flavor of the wood. Customize the exact level of toasting to suit the requirements of each type of wine. The wooden staves are softened by temperature before being bent to form the barrel. The barrels are assembled using traditional techniques but apply modern technology to ensure absolute water tightness. Depending on the customer's request, the level of toasting from light, medium to strong will be adjusted, highlighting the characteristic flavor of oak. Vicard offers 4 different burning methods to meet the diverse needs of customers. 1. Standard burning. The barrel is steamed for 3 minutes to increase humidity, then burned at a temperature of 140 to 190 degrees Celsius. V12 burning system. Burning the barrel with steam and hot air, creating a complex and delicate flavor. 3. E3. Washing the barrel 3 times to create a soft flavored wooden barrel. 4. Gradual toast. Burning the barrel at different temperatures to create a diverse flavor. Each wooden barrel is strictly tested to ensure tightness, durability, and uniformity. The company also provides detailed reports on the production process and wood origin for customers to follow. Thanks to VG7 technology, Vicard casks have a consistent flavor profile, minimizing variation between batches. Customers can choose the type of wood, toasting level, and barrel size to suit their needs. Combining tradition and cutting-edge technology, Tonellerie Vicard not only creates high-quality casks, but also contributes to shaping the style of wine and spirits around the world. OSCA is one of the prestigious manufacturers of hand tools, specializing in providing hammers for many fields such as mechanics, construction, and carpentry. With a philosophy focusing on quality and performance, the company has invested heavily in modern production technology to create products with high durability, optimal design, and outstanding efficiency. OSCA's high-quality hammer manufacturing begins with careful material selection. For the hammerhead, high carbon or alloy steel is chosen for its strength and impact resistance, with the specific grade depending on the hammer's intended use. The handle, traditionally made of shock-absorbing hickory wood, may also be crafted from modern materials like fiberglass or composites, or even steel for specialized applications. The hammerhead's shape is formed through either forging or machining. Forging, the more common method for high-quality hammers, involves heating a steel billet and shaping it under powerful presses using a series of dies. This aligns the steel's grain structure, resulting in exceptional strength. Alternatively, machining, often used for specialized hammers or prototypes, utilizes CNC machines to precisely cut the head from a solid block of steel. Heat treatment is a critical step in the process. The hammerhead undergoes hardening, where it's heated and rapidly cooled to achieve extreme hardness. This is followed by tempering, a lower temperature heating process that reduces brittleness and increases toughness, preventing the head from shattering upon impact. After heat treatment, the hammer head goes through several finishing stages. Grinding and polishing remove imperfections and achieve the desired shape and smoothness. Some hammerheads are also coated with paint, lacquer, or other finishes for corrosion resistance and aesthetic appeal. C45 induction hardened steel, smoothed, lacquered, polished, and blunted edges. Patented 3-component handle, nylon, non-slip rubber grip and protection, aluminum alloy core. Vibration-free, mechanical head fixation with steel wedge and red epoxy resin. Throughout the entire manufacturing process, rigorous quality control measures are implemented. Dimensional checks ensure adherence to specifications. Hardness testing verifies the effectiveness of heat treatment. Impact testing assesses durability, and visual inspections check for any defects. The machines involved in hammer manufacturing are diverse and specialized. Forging presses, either hydraulic or mechanical, provide the immense force needed for shaping the steel. CNC machining centers are used for precise machining when required. Heat treatment furnaces maintain precise temperature control for hardening and tempering. Grinding and polishing machines achieve the desired surface finish. Painting/coating systems apply protective or aesthetic coatings. Assembly presses are used for handle attachment, particularly for wooden handles. Finally, testing equipment, including hardness and impact testers, ensures quality. Modern factories also frequently incorporate robotic arms for material handling and automation. With modern production processes and strict quality control systems, OSCA has created high-quality hammer products that meet the strict requirements of customers worldwide. From raw material selection, machining, heat treatment to assembly and quality control, each hammer is manufactured with high precision to ensure durability and optimal performance. Wade Ceramics, one of the most famous ceramic brands in the UK, was founded in 1810. The company is based in Stoke-on-Trent, which is known as the ceramics capital of the world. With over 200 years of experience, Wade Ceramics is famous for creating high-quality ceramic products, from homeware, souvenirs, to specialty products such as porcelain bottles for the spirits industry. Wade always combines traditional manual production techniques with modern technology, helping to create products that are both beautiful and sustainable. Wade Ceramics uses high-quality white clays, mainly from the UK and Europe, known for their toughness, heat resistance, and outstanding durability. Minerals such as feldspar and quartz are added to increase the hardness and strength of the product. The clay is cleaned, crushed, and mixed with water in large tanks to create a plastic mixture called slip. The filtering and deadhesive process ensures consistent raw material quality, free of unwanted particles. Slip is poured into plaster molds, a traditional technique that shapes the product with high precision. Some special products, such as limited edition collections, are still hand-molded by artisans to maintain their uniqueness. After shaping, the product is dried naturally or in a specialized kiln to remove excess water. This stage requires strict control to avoid cracking or deformation. The product is fired at a temperature of about 1,000 to 1,200 degrees Celsius, creating initial hardness and completely removing moisture. A special glaze is applied to the surface to create gloss, color, and protect the product. After being glazed, the product is re-fired at a higher temperature, 1,200 to 1,400 degrees Celsius, which helps fix the glaze and increase durability. Wade Ceramics is famous for its sophisticated decorative details. The designs can be hand-painted by skilled artisans or printed with high-tech heat transfer. Some special products are also plated with gold or platinum, creating a luxurious and classy look. Each product undergoes strict testing for durability, color, and aesthetics. Products that do not meet the standards will be removed or recycled. Wade Ceramics is a symbol of sophistication and quality in the British ceramics industry. With a closed production process, attention to detail, and a combination of tradition and modern technology, Wade Ceramics products are not only ordinary items but also works of art, bearing a strong cultural mark and sustainable value. Asia Match Company Private Limited, as a leading manufacturer of safety matches, recognized for high-quality products, efficient production, and a commitment to safety and sustainability. They likely serve both domestic and international markets, utilizing a highly automated, machine-driven process. The manufacturing begins with splint preparation. Suitable wood, like aspen or poplar, is selected for its straight grain and low resin. Logs are debarked and processed into thin veneer sheets using a rotary lathe. These sheets are then fed into a chopping machine, precisely cutting them into individual splints of the desired dimensions. Critically, these splints undergo an impregnation process to prevent afterglow. They are immersed in an ammonium phosphate solution, which penetrates the wood fibers. This chemical, upon burning, releases phosphoric acid, creating a char layer that blocks oxygen and extinguishes any embers. Following impregnation, a drying system removes excess moisture. Finally, the splints are dipped in molten paraffin wax, providing a fuel source for sustained ignition and some waterproofing, leaving the head end uncoated. A heated tank and precise dipping mechanism ensure a uniform wax coating. The next crucial stage involves the match head composition and application. The safety match head is a complex mixture, including potassium chlorate oxidizer, sulfur or antimony trisulfide fuel, glass powder friction, glue binder, and fillers/dyes. The striking surface on the box, separately, contains red phosphorus, glass powder, and a binder. Ingredients for both are meticulously mixed in specialized machines, often in a wet state to minimize dust explosions and ensure uniformity. The core of this stage is the head application, commonly done with a match head dipping machine. Prepared splints, held in continuous chains or frames, are passed over rotating drums or rollers, partially submerged in the liquid match head composition. Precise dipping depth and speed control ensure a uniform head size. The matches then pass through a multi-stage drying tunnel with controlled temperature and humidity to prevent cracking and solidify the head. Multiple dipping stages may be used for specific match types. The striking surface is applied to the box via printing or coating, typically using a roller or screen. Box preparation and filling are equally automated. Box-making machines cut, fold, and glue cardboard to form the inner and outer boxes. Automated box filling machines then count and insert the dried matches into the inner boxes using vibratory feeders and precise mechanical arms. Filled inner boxes are inserted into outer boxes, sealed and packaged into larger cartons. Each product must undergo a rigorous quality inspection process before leaving the factory. The company uses an automatic testing system to evaluate the flammability, burning time, durability of the matchstick, and the level of safety when used. The qualified matches are then packaged by an automatic packaging machine, ensuring the product is uniform, accurate, and optimizes production capacity. Asia Match uses many modern technologies and machines in the production process, including automatic wood cutting and matchstick forming machines, industrial drying systems, automatic match head covering machines, matchbox production lines, and automatic packaging systems. Thanks to that, the company ensures stable product quality, matches burn evenly, do not go out or burn too strongly. In addition, Asia Match's products have many outstanding advantages, such as high safety, well-controlled chemical formula to prevent fire spread, and the application of advanced production technology to reduce errors in the production process. In particular, the company focuses on environmental protection by using renewable wood materials and limiting toxic chemicals. With modern production processes and strict quality control systems, Asia Match has affirmed its position as one of the world's leading match manufacturers. Thanks to continuous improvements in technology, the company constantly improves product quality, meets the needs of the global market, and brings absolute safety to consumers. Fiskars is one of the oldest and most prestigious brands in the hand tool industry, especially gardening products such as shovels, pruners, and axes. Founded in 1649 in Finland, the company is famous for its products with convenient design, high durability, and superior quality. The factory in Oslo plays an important role in supplying gardening tools, including a high-end shovel line manufactured using modern processes. The main raw material for creating Fiskars shovels is high-grade boron steel, which increases durability and load-bearing capacity. The steel plate is cut into standard sizes before being put into the production process. Next, the steel plate is put into a furnace at a temperature of about 1,200 degrees Celsius to soften before being stamped by a hydraulic press, with a pressing force of 800 to 1,000 tons. After preliminary shaping, the steel is rolled to the desired thickness and shape before being precisely shaped using an automatic cutting press. To increase durability, the shovel blade is heat-treated in two main stages. The first is the tempering process, in which the steel is heated to about 850 to 900 degrees Celsius and quickly cooled with oil or water to increase hardness. The steel is then tempered at a temperature of 200 to 300 degrees Celsius to reduce brittleness and increase elasticity, giving the shovel better resistance to force in actual working conditions. After heat treatment, the shovel is welded and the handle is attached. If the shovel has a connecting neck, the welding process is carried out by an automatic welding robot to ensure high precision and structural strength. Fiskars shovel handles are usually made from polymer-coated steel, aluminum, or composite wood, which reduces weight while still ensuring strength. The handle attachment process uses a high-pressure press to firmly fix the blade and handle. The next step is surface treatment to protect the shovel from environmental impacts. This process includes electrostatic painting with a special anti-rust paint, which gives the product greater durability and good corrosion resistance. Before leaving the factory, each shovel must undergo a rigorous quality control process, including testing for durability, load capacity, and blade sharpness to ensure it meets Fiskars' high standards. Thus, the production process at the Oslo factory has helped Fiskars create top-quality shovel products that meet the needs of consumers around the world. With the combination of high-quality materials, modern production technology, and strict quality control processes, each Fiskars shovel is not only durable but also brings the best user experience to customers.